Hello, and welcome to 9.3. Okay, this one's just a little bit different, but not a lot. Before, everything had to be independent. Now today, we're going to check means on dependent data, or matched pairs, which is what it's more commonly called. You will need stat disk, so make sure you have that up and going, and let's see what we can get done here. All right, we're going to identify the sample data consisting of matched pairs, so we have to make sure they're matched in some way. We're going to conduct, a formal hypothesis test to see if this works or not. For the means is what we're going to use today. And we're going to construct confidence intervals for the means between these differences. Now, when you're designing this experiment, planning an observational study using dependent samples with matched pairs is generally better than using two independent samples. So what that's saying is making sure that you can do this all at the same time. It makes life a little simpler. Notation for dependent samples. D represents the individual difference between the two values in a single matched pair. So you're going to subtract them. You have to find the difference between this matched pair. So this here is the mean of those differences. This is the mean for the population, sorry. This is the mean of the differences for the paired sample data that we have. We're going to find the standard deviation of the differences for the paired sample data. And then N is the number of pairs that we actually have. So nothing hard, but we have to keep track of our symbols. Okay, the sample data had to be dependent this time. That's new. Still a simple random sample. This is also an OR. It either has to be greater than 30 or it has to be a normal distribution. This is actually a very loose requirement this time. If it doesn't happen, it still actually works. We still do have a test statistic formula we can use, but we will be using stat disk, and we'll be using it for the p-values and the critical values. And your degree of freedom is n-1 again. Our confidence interval will be the difference between your means minus your error plus your error with your population difference in the middle. Okay, let's go and see how we're doing here. First thing we have to do is verify that is a dependent sample or it has a matched pair. We have to look for our differences. We have to find the value of the differences and the standard deviation of them. And then we have to create a hypothesis test and a confidence interval. All right. They are all three equivalent methods. You will get the same result from all. Here we go. We have an example of best actresses are generally younger than best actors. This here is by Oscars of best actors and actresses. It's according to year. So they are paired because this is 1 year. And then this guy is the next year that this happened. And then this guy is the next year that this happened. And then this guy is the next year that this happened. So you can see they are paired data because they come from the same year. All right, we're going to enter this into stat disk. So enter those two into your first two columns, and then we're going to help you out a little bit here. All right, so we've entered in our data. Well, in order to get our differences, stat disk will do this for us. So what you need to do, everybody ready? So you need to click on data. Okay, now if you go down, there's a simple transformation, and that's what we're doing because we're just subtracting them. So sample transformation. The first column is we're going to use column 1. All right. The operation we're going to do is we're going to subtract them. So we're going to take column 1 and then we're going to subtract column 2. All right. We want to put this in column 3 is where I want my answers to go. So 1 minus 2, put the answers in 3. Fit basic transformation. Oh, I forgot to do column instead of constant, my fault. There we go. All right, now we have our transformation over here, and these are the numbers we're going to use to calculate with. So next, we have to go back to our notes here. We have to check our requirements. Are they dependent? And the answer is yes, they were matched by years. So we've got that one checked. Are they randomly selected? We don't know which years they are, so we're going to assume they are randomly selected. The number of pairs is 5. Not very large, but at least it meets it. So now we're going to check for normality. When you ran it through the Reiner joiner, it's good enough. So we're going to say it passes, so we meet all requirements. All right, so first claim we're going to say is that, so now we're going to do our hypothesis testing. The differences have a mean less than 0. All right, so we're going to say that the differences have a mean of less than 0. So the mean is less than 0, so that's saying that the ladies are younger. Okay, if the original claim is not true, then it has to be greater than or equal to 0. So this is the opposite. So that means our null always includes the 0. So this guy is our null, so it equals 0. And then our alternative, which is this one, is the one that doesn't include the 0. So it's got to be less than. We have a significance level of 0.05. We're going to use a t-distribution because it's a mean. And then we're going to find the value of the test statistic using StatDisk. So now let's get back to our StatDisk here. So now we're going to go to analysis, hypothesis testing, a mean of matched pairs this time is what you're using. Significance of 0.05. Select which two columns of data you would like to compare. So we're going to compare 1, and we're going to compare 2, and we're going to evaluate. All right, now you need to record all of that in your notes. So get back to your notes here and record those values. So when you go down here, our D was negative 10.2. Our standard deviation was 14.7. Our test statistic was negative 1.5565. Our p-value was 0.09728. Our critical value was negative 2.1318. So when we look here, our test is here. Our critical is down here at a negative 2. So that would tell me I am rejecting the null. My p-value is 0.09, which is greater than 0.05. I'm sorry, I just said that wrong. Your critical value is here, right? So if my critical value is negative 2.1 and my test statistic is negative 1.557, it does not fall here, so we failed to reject the null. Now let's look at our p-value, 0.09 is greater than 0.05. Again, we failed to reject the null. Now let's go down to our, I think this is actually on the next page for you. Critical value is there. Interpretation, there's not enough. So if we fail to reject the null, there's not sufficient evidence to support the fact that the mean value is less than 0. So there's not evidence to support the claim that for the population of ages of best actors and actresses, the difference have a mean less than 0. This is not evidence to conclude that the best actresses are generally younger. It just says that we cannot do that. So don't forget this. This is just statistics. All right, these are the answers you got when you typed it in. It's already printed out for you. Okay, our confidence interval is right here. And if you look, 0 is in here. So we are 90% confident that the limit of negative 24.2 and 3.8 contains the true value of the mean. All right, since that includes 0, we cannot say they are different. All right, good luck on your homework. I hope you do well. Make sure you're using StatDisk and you're showing your requirements. Have a great day.